We are Team Updraft 54, and you may be wondering,
what is this?
This is a model updraft tower. The sun is a huge source of renewable energy which can be harnessed by a solar updraft tower. The sun heats up air below a greenhouse which rises up the tower, spinning a turbine and generating electricity. Relative to other renewables, a solar updraft tower is simple, consisting of just a tower, a greenhouse and a turbine. However, it has very low efficiency. But wind speed is significant at a height of 200 metres. How can we make use of this? Our design question was, how can we unlock this wind generation potential of a solar updraft tower? Above the tower, flow separation occurs, forming a low pressure suction zone, which could be used to drive the turbine. Although this suction effect is well known, it was unquantified until we conducted novel experimental testing. This fed into our theoretical model, which showed the need for a novel rotating gate to force air into a high pressure zone at the base. This pressure difference drives flow upwards. We predicted that this would triple the power output of the Manzanares solar updraft tower, justifying further exploration. Because of the novelty of this concept, wind tunnel testing was required to validate our theory. The tower was modelled as a large pipe and the turbine as a porous disc. Power output was calculated as force times velocity. As expected, flow separation occurred at the top. Without the gate, the effect of suction was cancelled out. However, with the gate, air was sucked up the tower. No gate, no power, but with the gate, power was generated. Dynamic oscillation was observed, so a boundary layer fence will be required to disrupt vortex shedding. Our experimental results showed excellent agreement with theory. Using the optimum geometry determined in the wind tunnel, a 2-metre tall outdoor model was designed.
Why are you testing it outside?
Yes, why outside? To validate our design's performance in variable wind conditions. Returning to Manzanares, our full-scale design is a steel modular tower supported by 6 ties, with trusses acting as boundary layer fences. In wind operation mode, the open gate directs air through the turbine. In solar mode, the gate closes, allowing hot air to flow up the tower. By harnessing the wind and sun, our novel design significantly increases both the power output and competitiveness of the solar updraft tower. Could this be a major step forward in renewable energy generation?